In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are family partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunity into success stories. These success stories can be monetized into value addition. Thank you very much for your precious time. Okay, today I'm going to discuss my lecture number 2, downstream refining of production facilities, light FCC, gasolines, extractions and sweetening, heavy hydrocarbons, hydrogenations, hydrofinisher, hydrotreater and polymerizations. Lecture number 2. Before my lecture, I used to read the Quranic verse, Qala Rabbi Shrah li Sadri wa Yassir li Amri Wahlul Uqdatam min Lisani Yafqahu Qawli Allahumma Rabbi Zidni Ilma. O my Lord, open my chest and ease my task for me and loose a knot from my tongue that they may understand my saying. Allahumma Rabbi Zidni Ilma. O Allah, advance me in my knowledge and true understanding. Okay, my future plan to discuss 6 topics related to refining facilities. So we are still working on light hydrocarbon, a sweetening Marex unit. Okay, so next topic will be a sweetening a liquid petroleum gas, LPG, Marex. And then we'll discuss fundamental principles of liquid petroleum LPG hydrogenations. Then heavy hydrocarbon, hydrofinisher. So the fundamental principles of light cyclic oil hydrotreater. And number 6, we will discuss LPG polymerizations. That will be 6 topic we are going to discuss next couple of months. It could take maybe a year. Okay, shaping the clean and sustainable global energy, plan to deliver a more than 300 lecture next couple of years. Okay, so just we are discussing light naphtha sweetening principle. Part 2, we will have a plan to operating windows, process, instrument, interlocks, startup shutdown, troubleshooting, corrosion involvement and treatment and performance monitoring, etc. Okay, refining production facility, FCC gasoline extractions and switching process of flow descriptions, lecture number 2. Okay. Okay, key takeaway points, lecture number 2, downstream refining production facilities, extraction sections, reactor and regeneration section we are going to discuss today. Okay, process of flow descriptions. As you know, the sweetening unit has 3 main segments, 3 main sections. First is the extraction sections. Caustic soluble mercaptans are mostly extracted from the gasoline. Number 2, reactor sections. Remaining mercaptans converted into disulfides by catalytic oxidation in the alkaline environment. Caustic regeneration sections. Extracted mercaptans are converted to disulfide oil. Basically, the light FCC gasoline sweetening or gasoline mercaptan oxidations is a UP trademark. It consists of an extraction, reactor and regeneration sections. In the extraction section, the caustic soluble mercaptans are mostly extracted from the gasoline. In the reactor section, the remaining mercaptans are converted to disulfides by catalytic oxidations in alkaline environment. In the caustic regeneration section, the extracted mercaptans are converted to disulfide oil. Then the sulfide oil is separated from caustic solution and the regenerated caustic Marex solutions recirculated to the extraction sections. Okay, so from my next slide, I'm going to explain you the extraction, reactor regeneration, how it's happened in one artificial simulated models. Okay, light after treatment artificial simulated model, which I'm going to. Okay, yesterday we have discussed only startup procedure. Today we are going to discuss complete its extraction section, reactor section, and regeneration section. Okay, this is my feed composition, and after processing I'm getting a very good product as granted. So first I run the model, step 1, step 2, step 3, step 4, step 5, 6, 7, and step 8. Okay, so I will keep my product and hide, and then I'll bring my operating parameters. Okay. Now, light gasoline from the gas concentration section of FCC unit is first routed to extractor. The mercaptan present in the light FC gasoline have a low molecular weight and are readily soluble in caustic soda solution. For this reason, the gasoline is brought in contact with caustic soda solution in an extractor. The extractor is equipped with 8 trays. Regenerated caustic is fed flow controller to the top of the extractor, while gasoline is fed to the bottom of the extractor. The spent caustic is discharged from the bottom of the extractor as a function of level in disulfide separator and transferred to the caustic regeneration sections. Okay, this is my extractor section. Okay, now I'm going to discuss my reactor section. Okay, this is my reactor sections. Okay, the pre-treated gasoline overhead product of extractor is directed to the reactor. The fixed bed reactor is filled with activated charcoal impregnated with water-soluble Marex catalyst. In reactor, the remaining mercaptan in the gasolines are oxidized in the required alkaline environment, which is adjusted by adding highly diluted caustic soda solution. Okay, the pressure in the system is kept sufficient to ensure that the air required for the oxidation dissolved in the hydrocarbons is met. Caustic soda solution with the strength, that is diluted caustic soda, it's coming from the other side, mixed with the concentrated caustic coming from the other unit with the process, waters, and the soda solution and the small amount of Marex plus cutters are injected into the gasoline stream or through atomized nozzles, ensuring uniform dispersion in the feed. Continuous injection of dilute caustic required to maintain a minimum level of alkalinity in the reactor. Then air is added through FCV flow control valve to the gasoline stream via air mixing to ensuring consistent dissolutions of air in the gasoline are just before entering the reactor. This air injection line is provided with shutter valve which cuts off the air flow on the low gasoline flow rate. An excess amount of air injection for a given feed rate can cause the formation of separate air phase at the top of the reactor, which will promote a channeling in the catalyst bed. The mixture of gasoline, air, and soda solution is evenly distributed on top of the active charcoal bed and then run through the reactor. The spent sodium hydroxide and OH solution is led via the bottom nozzle of the reactor to the drain pot, where the remainders of intended gasolines are separated. Then the spent catalyst is discharged through level control to the spent caustic degasser drum. Okay, the gasoline leaves the reactor's separate stream at the bottom of the catalyst bed after inhibit injections, that is provided by the UP inhibitions. The gasoline is exported a pressure control to the PCV to maintain a certain. During operation, the catalyst is losing its activity and needs reactivations. The catalyst will be reactivated, and the acetone washing the activated charcoal is the first step, and the second re-impregnations are with Marax catalyst. So the different equipment will be provided for catalyst washing and re-impregnations, circulations, a pump, ejectors, different equipment will be in place. Okay, so we'll further discuss this equipment in a special procedure process, or we will have another lecture. Okay, now we are going to discuss it's how the caustic regeneration section is performing. Okay, now we are going to discuss caustic regeneration section. Okay, this is complete regeneration section. The mercaptan loaded caustic from the bottom of the extractor flows via caustic heater oxidizers. Before entering the oxidizers, flowing fluids are mixing up with the rich caustic. The Marax catalyst from the catalyst additions is periodically added to the caustic to maintain steady caustic activity. For oxidization, air is needed, which is added a flow control to the caustic catalytic mixtures. To promote a separation of the caustic and disulfides, wash naphtha is injected to the mixtures caustic with catalyst and air upstream of the oxidizers. This mixture passes through the oxidizers from bottom to the top, while the mercaptans polluting the caustic are converted to disulfides. After leaving the top of the oxidizers, they steam into the dome of the disulfide separators, where the gases and the liquid phases are separated into off-gas, sulfide oil, and wash naphtha and caustic. Okay, the off-gas leaving the disulfide separator dome to routed a pressure control through PCV to the heaters in a heavy FCC gasoline hydrofinishers and or in hydrotreater, LCO hydrotreater. In the case of failure, the other unit, the off-gas is routed to vent duct, where it is discharged via exhaust head to atmosphere at the safe location. During normal operation, the off-gas route is set by operator using selector switch. From different route to can be chosen. Fuel gas is added flow control to the off-gas for the purging and reducing the oxygen content in the off-gas to stay below explosive limit. In the lower part of the disulfide separators, the disulfide oil naphtha mixture is separated from the caustic and leaves the vessel on the top of the lower body. After passing through the disulfide, a sand filter, the disulfide oil naphtha mixture is extracted by the means of disulfide pumps using two reactor sections. Wash naphtha is added in the system and better separation for disulfide and regeneration caustic to disulfide separation system. Okay, the wash naphtha coming from the naphtha hydrotreater is injected through FCV to the suction side of the caustic circulation pump. Regenerated caustic wash naphtha mixture is pumped a wash naphtha where they settle and separate. The regenerated caustic is returned from the bottom wash naphtha settling extractor. Wash naphtha leaving at the top of the wash naphtha filter is split into two streams. One stream is recycled to the suction side of the caustic circulation pump, and the other is routed a level control to the oxidizers. Okay, this was my last slide, and this is last slide, and we have discussed regeneration section. Okay, conclusion: achieved product quality as granted. First, you can see here this is my expected feed to the sweetening unit, and after that, this is my product after processing. Okay, so thank you very much for your patience, time. This was my next topic, unit design based theoretical description of the process and material and heat balance. Okay, references: Qatar Petroleum, Oil and Gas Development Corporation, Pakistan; World Energy Outlook; U.S. Geological Survey; U.S. Department of Energy; Schellenberger; International Energy Agency; Wikipedia; Oklahoma State; State Oil; Northwest, the story of the oil in Pennsylvania, a liquid natural gas from Wellhead to one pit. Okay, together, everyone achieve more. Please do not hesitate to send me your feedback, comments, t.masood.dr@both.edu. Thank you very much for your precious time. Please stay at home, stay safe, inspired, and blessed.